Alright, so this is the last lesson in all of Unit 7. This is lesson H3, and this is about areas of triangles using trigonometry, specifically using sine. Can you see that? Yeah, I guess if I tilt it, you can see that. Okay, so just a real quick refresher. I'm going to use X, Y, and Z as my vertices down here because A is the what we use for area, and I don't want that to be confused with the vertice. So this is big X, right? This is big Y, and this is big Z, right? So this would be little y, this would be little x, and this would be little z, right? So yeah, I guess they're a little hard to differentiate, right? But remember, if I wanted to find the area of anything, and I'm given, two of the three, two angle or one angle, right, and two lengths, which I'm given in all of these, I'm given one angle and two of the lengths, right? I use those, and remember the area for a triangle is 1/2 two lengths, the base and the height. And for the instance for this one, we have to use the sine of that one of those angles, right? So in this case, we say that we use, say we're given x, right? We're given the angle x. We know this is the known. We know this is theta. We are given theta. All right, just for a refresher. So we're given z and y, right? So it's gonna be 1/2 z times y, and then times the cosine. The sine times the sine of theta of big X, right? So that is the pattern that you go after. You could also rewrite this as area equals z times y times the sine of x divided by 2, because that is mathematically equivalent. Okay, just remember it's the two lengths that you know, right? Multiplied together, and both of those multiplied by the angle, the sine of the angle adjacent to, or opposite of the angle, the length that you don't know, divided by 2. Okay, so let's get down to these, and we'll maybe not even have to draw triangles for these ones, but I guess we could reuse the patty paper for this. Okay, so let's go ahead and say we have triangle B. Let's maybe try to reuse this more often. We have triangle B, H, and Z. B, H, and Z. So we have, this one is missing Z, so this is 7. This is missing H, so that's H, so that's 12. And this is angle B as the middle one, so this is angle 64. So that's exactly what we need, right? So our area is going to be equal to, I can write it up here, our area is equal to, I don't know if you can see that, or maybe I can move it over without, how about I just slide the book? I can't slide the book up anymore. Okay, I did it. Okay, our area is equal to, I'm going to do the divided by 2 because that's the way I like it. I think it's cleaner. Okay, it's going to be equal to Z, right, which is 7. I'm just going to put the numbers in. Right, 7 times 12 times 12 times the sine of 64. All divided by 2. So I always like the sine of 64. Less likely to have a calculator error. Times 7 times 12 equals, and divide that by 2. So the area equals 37 37.7 units squared. Okay, so the next one, we have triangle Y. I have triangle Y, CJ, C, Y, C, and J. And then we have CY, so this is adjacent to J, is 100. We have JY, so that's opposite. Sorry, it's opposite. It's opposite of C, so that's 63. And then we have angle Y is 80. All right, so it falls into what we need again. So the area is going to be equal to 100 times 63 times the sine of 80 divided by 2. 80 sine times 63 times 100 divided by 2 equals 3,102. 3,102.1 units squared. Okay, moving on to the next one. All right, so the next one is KDN, KDN, SF, or what? Okay, yeah, oh yeah, well, I got way off there. All right, so KDN. All right, so DN, that's opposite of K, is 7.2, and K, that's opposite of N, that's 6.3, and angle N is 95. 95. All right, so this let me see if I got everything right here. Angle N. Oh, this isn't right. I transposed my stuff wrong. DN, this is opposite of K. Okay. NK is opposite of D. Starting to break down because I'm hurrying. This is wrong. This is 6.3. Okay. Excuse me. So there is a question there. So if you didn't know that one of these angles, these line measurements at these angles, what would you do? Well, you use the law of sines or law of cosines to find out that angle or that line measurement or the angle that you need. So there you go. So now that you know that, it's the area equals, let's see, 7.2 times 6.3 times the sine of 95 divided by 2. All right, so 7.2 times 6.3 times 95 sine equals, divided by 2 equals 22.2 or 225.9. I must have fat fingered something. Let's try that again. 7.2 times 6.3 times, I definitely did, times 95 sine equals, divided by 2 equals 22.59. That's more correct. Equal area equals 22.6. All right. All right, the next one. Let's shift to green. I haven't done green yet. All right, so we have FSG, SF, SF, that means it's opposite of G, it's 3 square root of 5. And then we have GS, that means it's opposite of F, it's 2 square root of 7. And then angle S is 36. 36. That's what we need. The angle sandwiched between the two sides. So the area equals 3 square root of 5 times 2 square root of 7 times the sine of 36 divided by 2. All right, so I'm going to make some notes here. Square root of 5 times 3 is approximately 6.71. 7 square root times 2 equals approximately 7.29. And then we have, all right, so I'm going to multiply 6.71 times 7.29, and then multiply that by the 36 sine, and then divide that by 2 equals, it says 14. Let's see, it did not match the thing. Let me try that again. 5 square root of 3, 5 square root times 3 equals 6.71 times 7 square root times 3 equals 5 square root of 3 times 36 times 36 sine equals, okay, and then divide that by 2 equals, that's still not what it says. All right, let me pause this and see what I'm doing wrong. I think it was just a operator error of the calculator. I just operated it in different sequence. So I did this instead. I did 5 square root times 7 square root times 3 times 2 times 36 sine equals, and then I divided that by 2, and then that equals what the key says. So it was just calculator operator error, and that's what the key says there. Okay, so like you can remember, you can smash the radicals together, and first square root of 3, square root of 5 times square root of 7, and then do the whole numbers next. It doesn't matter, you don't have to do them with their paired whole number. So there's a pro tip there. All right, moving on to the next one. So like I said, I'm going to continue to draw my triangle and check it off of my triangle. Oh man, this has gotten really small. I'm going to have to shift my book and try not to lose you. Okay, so I'm going to continue to check it off of a triangle. Just a generic one, because you never know when they try to throw a curveball at you and give you the wrong sequence of angles and line segments, right? So you always want to check it So I'm gonna do that. I'll grab another piece of patty paper real quick. There's, any random angle or any random triangle. It's just to check the sequence and stuff like that, so you can wrap your brain around it. Okay, and I didn't need to make it that big. It's gonna make me burn through patty paper faster. So I'll make it a little smaller, I guess. Alright, there's my test triangle. And I'll grab a new piece of patty paper to follow along. Alright, so we have WQL. WQL. So we have QW, that's L, that's 8.4. We have LW, that's 9.9, also known as Q. And then we have W, that's 68. 68. Alright, so we have, that's the right pattern. So we will do the area equals 8.4 times 9.9 times the cos or the sine of 68 divided by 2 equals 8.4 times 9.9 times 68 sine equals divided by 2 equals 38. Scroll down, make sure it's right. Equals 38.6. Okay, 38.7 if you're rounding up, but that's fine. The key says 38.6. Alright, next one. Shift to, I haven't done dark blue yet. Let's do dark blue. Alright, oh, here's some fractions. Okay. I'm just going to convert these to decimals right away, so I don't have to deal with fractions in my fraction. Alright, so we have BRS. BRS. Alright, so little b is 75 or 78 divided by 5, also known as 15.6. That's 15.6. And then RB, also known as little s, equals 11 divided, or 119 divided by 8. 19 divided by 8 equals, okay, I'll do the whole thing. 14, this is 15.6. 14.875, and then this is okay, and then we have, so this is 14.875, and then we have angle R, and that's in between there, so that passes. So then we do the area equals 15.6 times 14.875 times sine of 42 divided by 2 equals 14.875 times 15.6 times 42 sine equals divided by 2 equals 77.6. 77.6. Okay. Then we have another one. Let's go to red. Let's go to red. All right, we have TXD. TXD. TX opposite of D equals 2.6. TD opposite of X is 5.1. T is 16 degrees. Passes the check. Okay, so we can say that the area equals 2.6 times 5.1 times the sine of 16 divided by 2. So then we can, so they'll do the math, plug and chug, times 5.1 times 16 sine equals divided by 2, and the area is going to be equal to 1.8 units. These are all units squared. Okay, next one. Oh man, we got some radicals. 11 times 11 is 11. Let's see if it passes that. Or sorry, 11, the square root of 11 times the square root of 11 is 11. That's a cool little thing to see. Alright, but let's see if it passes the right pattern. So y and k equals, alright, so ny is square root 11, and k is square root 11, angle n, it passes the pattern. Okay, so area equals square root of 11 times square root of 11 is 11 times the sine of 72 divided by 2. See, 11 squared times, correction, square root times 11 square root equals 11, just to prove it to you, times 72 sine equals 10.46. Oh, we've got to divide by 2. No, it's 5.2 equals, area equals 5.2. All right, and then we got, let's see if this one passes it. LGR. Let's change it to red. LGR. That GL is 521. We got LR is 94. And we got L is 179. Didn't try to trick us. I'm surprised they didn't try to trick us. So we can use the area equation. Don't have to do any fancy stuff yet. Okay, so the area equals 521 times 94 times the sine of 179. 179 divided by 2. Alright, that's an obtuse angle. Alright, so triangle 521 times 94 times 179 sine equals divided by 2 equals, area equals 427 units. Units squared. 427.4 units squared. Alright, last one. I'll go with orange. Oh, where's my triangle? Oh, there's my triangle. Okay. Last triangle we have ABC. A, B, and C. BC is 5 square root of 3. AB is 4 square root of 7. Angle B is 89. It works. Okay, so we can do I don't know if you saw that or not. Sorry. Area equals 5 square root of 3 times 4 square root of 7 times the sine of 89 divided by 2. All right, so I'm going to do 4 square root times 7 square root equals times 5 times 4 equals times 89 sine equals times 2 equals area equals, let me punch those numbers again. Square root of 3 times the square root of 7 equals times 5 times 4 times 89 sine equals divided by 2 equals 48.5. 45.8. 45.8. Okay. So that's how you figure out the area when you have a triangle. The triangle, where'd my paper go? Whatever. My triangle that I have, that I'm given, the configuration must be set up so that you're given this one, these two line segments, and then the angle in between the two line segments. Okay? That's when that equation works. If you're not given that, and you're given some other variation, you have to use either the law of sine or the law of cosine to get those values, and then you can find the area. Then you can use this equation. Okay? So I hope that works and that helps. Pretty easy to find the area of a triangle using the sine and that equation, but just make sure that you're given the right stuff, and if you're not, find it using law of sine or law of cosine. Okay, so that wraps up Unit 7. I hope you guys love trigonometry as much as I do. That's just a brief exposure to it. Take a trig class if you want to know more. Trigonometry is awesome. You can use it a lot in the real world.